Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 14th, 2025, so about 3 days ago. The big hook here is that their model is not only more accurate than previous methods, but also runs 40% faster on key video depth estimation benchmarks. The paper is titled STream3R, Scalable Sequential 3D Reconstruction with Causal Transformer, and its architecture is really interesting, taking direct inspiration from the way large language models work. Essentially, this paper introduces a new streaming framework that treats 3D reconstruction like a language modeling task, using causal attention to efficiently process video frames one by one. Also, for those who want to get their hands dirty, the authors have released the project on GitHub. You'll find the inference code and pre-trained weights, along with examples for running different attention modes, including the streaming session with a KV cache. They also have a demo you can run. On Hugging Face, the STream3R model is ready to download, complete with inference code examples to help you get started with streaming 3D reconstruction. Alright, so this first figure gives a great visual overview of how the STream3R model works. At the top, you can see the input, a stream of images, kind of like a film strip coming in one after another. As each new frame is processed, the model builds a more complete and dense 3D reconstruction of the scene, which you can see progressively filling out below. The secret sauce is the caching mechanism shown at the bottom, where key features from past frames are stored and reused, which avoids redundant computation. Diving a bit deeper into this process, on the left, each image is first broken down into tokens by a VIT encoder. These tokens then go into a decoder that uses two key steps. First, self-attention within the current frame's tokens, and second, causal attention. Causal attention is what lets the model efficiently look back at the cached memory from previous frames, but not into the future. This whole pipeline produces the final point maps and camera poses, building up the incremental 3D reconstruction, which you can see on the far right. Alright, and here we get to see the model in action with some qualitative results on in-the-wild images. This figure compares STream3R against 3 other methods. The first column shows the input video frames, one with a person rollerblading past graffiti, and another with a skateboarder. The other columns show the resulting 3D reconstructions. If you look at the final column on the right, the output from this new model is noticeably more complete and detailed, especially when you compare it to the other methods. Moving to the quantitative results, this table evaluates single-frame depth estimation across 4 different datasets. The main metrics are absolute relative error, where a lower number means better performance, and a delta accuracy score, where a higher number is better. If we look at the results, the key takeaway is in the last row for the STream3R beta model. It consistently achieves the best or second best scores. For instance, getting the lowest error on the Sintel, Kitty, and NYU v2 datasets, backing up those high-quality reconstructions we just saw. This table then details the performance on video depth estimation, which looks at both per-frame quality and consistency over time. The key comparison is against CUT3R, the previous state-of-the-art streaming method. Across all 3 datasets, Sintel, Bon, and Kitty, the STream3R models consistently achieve higher accuracy. And importantly, if we look at the FPS column, STream3R Alpha is about 40% faster than CUT3R, running at 23.48 frames per second versus 16.58. This shows a big jump in both accuracy and efficiency. And this strong performance carries over to full 3D reconstruction on the 7 scenes dataset. This table compares several methods using metrics for accuracy and completeness, where lower scores are better. The key comparison is again with the streaming method CUT3R. Here, the STream3R beta model achieves a mean accuracy of 0.122, which is better than CUT3R's 0.126. And just as importantly, it does this while being significantly faster with an inference speed over 20 frames per second compared to 17 for CUT3R. So wrapping things up, the key innovation here is successfully applying a causal transformer model to sequential 3D reconstruction. This approach not only provides higher accuracy than previous methods, but also significantly boosts speed, making it very promising for real-time applications. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.